Alright, so last video for this section, we're going to be looking at a histogram. Now remember, a histogram is where we're going to be comparing classes or groups of data together. In this particular example, we're looking at the English placement test scores. So you've got the test scores, but there's different ranges of test scores. There's so many different possible test scores, you wouldn't want to try and include each one of them, right? There's like 500 different scores you could get. And so you wouldn't want to include each one of them as its own bar, because you just have too many things you'd be looking at. So we group large numbers of them together into intervals, or into what we call classes. So a class then is the range, and if you're following along in your book, the previous page, so on page 538, there's a definition list. I'm not going to show the definitions here, but I'm just going to kind of talk through them as we're looking at this. The classes are the ranges here of numbers that contain data items. So it's just these intervals are the classes. The lower class and upper class limits. So each of these has a lower limit and an upper limit. The lower class limit is defined as the smallest whole number that belongs to a class. So if these end on decimals, then we actually want to go to the nearest whole number inside the interval. And the upper class limit is the largest whole number. The class boundary is another thing that we're going to be defining or using, and that is the number that is halfway between the upper class limit of one and the lower class limit of another. And then the class width is the distance between the boundaries of a class. And the frequency is the number of data items in a class. Okay, so that's how tall these are. Alright, so as we go through this, we're going to use those terms. So let's look at the questions here. How many classes are represented? Well, you can just, that's basically the number of bars. So 1, 2, 3, 4, 5, and 6. Okay, so there are 6 classes represented. Then it says, what are the class limits? I'm going to use a different color here. What are the class limits of the first class? Well, here's our first class. Apparently it runs from 200.5 to 250.5, but class limits are the whole numbers that are included. So I want the lowest whole number that's included, which would be 201, and the largest whole number that's included, that would be 250. Okay, so 201 to 250 would be the lower and upper class limits of the first class. Then it says, what are the class boundaries of the second class? Well, I go to the second class, and what I need to know in order to do that is the largest, it's the upper class limit of that one and the lower class limit of the next one. So the upper class limit would be 300, because that's the largest whole number. In the next class, the smallest whole number is 301. Okay, so 300 in the left, 301 on the right. And so the number that's halfway in between for the boundary is this actual 300.5. So 300.5 is the class boundary of the second class. Okay. It says, what is the width of each class? Now, generally speaking, they should all be the same. In most of these histograms, the class widths will be the same. It's a rare case where they're not. And in this case, they are. They're all 50, right? The class width is the difference between the boundaries. And so the boundaries are these, the 250.5 and the 300.5. If you subtract them, you get 50, and that's the same. It's consistent all the way down the line. Okay, which class has the greatest frequency? Well, then we go right to the biggest bar. So that class is the 250.5 to 350, or 300.5, sorry. So that class, the second class. And what is the frequency? I think they're calling it the second class, sorry, for that one. What is this frequency? Well, it's 16. So 16 people had that score. What percent of the scores are between 200.5 and 250.5? What percent? Okay. Well, we have our frequency on the left. That's the total number, not the percent. So what we need to do is we need to look at how many are in this category, in this class. The answer is 2, I assume, right? That looks like 2. So there's 2 in there, but then we need to know how many there are total. All right, so there were 50 students. I didn't really read all this. I'm sorry, I should have done that. Before you start, you should always read the paragraph and the titles. This histogram summarizes the score of 50 students. So if you have 2 out of the total of 50, if we didn't know that, we could just add up all the different bars, the heights, and you get 50 if you do that. So 2 out of 50 is the same as 1 out of 25. Or actually, I shouldn't reduce it down. Let's do it this way. 2 out of 50, if I multiply the top and bottom by 2, I'll get 4 out of 100, right? So 4 out of 100, this is a percent, that's 4%. So that means 4% of the students scored in this first class. Then it says, what percent of the scores are above 400.5? Well, 400.5 is here. The number of scores above that are the ones in the last 2 classes. That would be right here at 8, and this one is at 4, so it's a total of 12. Again, I would do the same sort of calculation. So there's 12 total above that number. 12 out of 50, if I multiply top and bottom by 2, I build this up to 100. It'd be 24 over 100, or 24%. So having a denominator of 50 makes that very simple to get my percentages. If I didn't have a 50 there, or a number that multiplied nicely to 100, I'd have to do a division and look at the decimal form of the percent. So, but these worked out real nicely. Okay. All right, that should cover us for all of our different charts. And the histogram, remember, is the one that groups a bunch of things into different classes or intervals. It just helps us to not have 50 different data points to look at. Right?